Remember, our ultimate aim in this section is to find a way that we can talk about the roots without having to find them, but I'm doing it the long way for now. Okay, so what does this mean? This means that when I look at this equation, can you see this equation over here? X squared minus 4x plus 3. As you can see, it's the form of a quadratic, so that means that it represents a parabola or a quadratic function. Oh, something happened there. Let's just try and get that smaller. Okay, or a quadratic function. And what we are essentially looking at here is we're saying, okay, to find the x-intercept, I must make this function equal to 0, and then I solve by either factorizing or using the quadratic formula. So I'm going to try and factorize first and see if that works. Well, I'm looking for factors of 3. The factors of 3 are just 1 and 3 because 3 is a prime number. So those are the only factors. And if I add those factors, can I get the number 4? That's what I'm looking for. So here I'm saying 3 plus 1 must give me 4. Okay, so that means that this set of factors is valid. Okay, so let's use those. Okay, so when we actually solve this, we can see that this actually factorizes, and I must have equal to 0 there, and I can say that's 3, and that's 1, and that's going to be x, and this is also going to be x. Okay, so this here means that the signs are going to be identical, the signs are going to be the same, and so that tells me that both are going to be negative because I take the sign of the middle number. And therefore, when I actually solve this, I can say that x equals 1 or x equals positive 3. At this point in time, you can see that these two things are my roots. This is considered R1, in other words, root 1, and this is considered root 2. And at the end of the day, when you look at this, you can now clearly identify to say that when I solve for roots, roots are just simply the x-intercepts, right? The roots are my x-intercepts. That's what the roots are. Okay, the roots are simply my x-intercepts. Okay, so at this point in time, I want you to look at this curve carefully, and I want you to say that, okay, we've now identified that there's actually two distinct values. There are two unequal or distinct values for these roots. There are distinct values for two roots. So we can say that these roots are unequal or they are distinct, right? Unequal values for those roots. Now I actually want you to look at the curve at this point in time and see what that curve looks like. So let's look at that curve. That is x squared minus 4x plus 3, and when I go to that curve, I can see that the intercepts are at positive 3 as well as positive 1. Do you see that? Positive 3 and positive 1. Now let's look at what we found over here. Positive 3 and positive 1. And therefore we can say we actually found the roots, and we saw that the roots are different, or the x-intercepts are different, and therefore they were unequal and they had distinct values for the two roots.